Good morning. So, let us get started with what we were doing last time. So far, we have seen the basic concepts in real time systems and scheduling requirements of a real time operating systems, and then we saw few open source real time operating systems. So, today we will continue with that discussion and we will look at few more important open source and commercial real time operating systems. So, let us proceed with that. So, last class we discussed a few free real time operating systems. We basically looked at the RTAI developed in a university situation in Italy, the RT Linux, ECOS and the Micro COS. Today we will look at a few more important ones. The ones that we look today used widely in many applications. We will first look at the VRTX. VRTX stands for Versatile Real Time Executive. It is developed nearly 30 years back by Reddy Systems. There are basically 2 or 3 persons in a small company, Hunter and Reddy company, 1980s, one of the very few real time operating systems which could be used in embedded applications, 1980s. And this was acquired by the Mentor Graphics, 1995. As I was saying that it is suitable for embedded applications, is widely used for system on chip architectures. See, many of these embedded applications are actually system on chip. So, a single chip takes care of the entire system, basically to reduce power consumption and to reduce cost and so on. Just a single chip takes care of the entire system's requirements, and VRTX is widely used on the SoC architectures and also the traditional board based embedded systems, which we had discussed to some extent earlier. It is used in both of these very widely. The original VRTX developed in 1980s had very few features, very little features, and after it was acquired by Mentor Graphics, features have improved and now it could be used with many sophisticated applications. Originally only 4 kilobyte in size, very rudimentary operating system, and did not support many of the required functionalities, and it could not be used as a full real time operating systems. Many aspects the programmer had to write himself or herself. But now, as I was saying that it has become more sophisticated, it can be used as a full real time operating system now. We will see that POSIX RT compliant and comes in 2 versions. One is the VRTX SA and the other is the VRTX MC. The VRTX MC is used for very small applications. MC stands for microcontroller, very small applications where power, cost, etc. are prime importance. But for medium and large applications, VRTX SA is used. The VRTX MC or the microcontroller version is optimized for low power consumption ROM and RAM sizes. The kernel again is very small, only a few kilobytes, intended for very simple mobile phones. Nowadays, of course, the cell phones are becoming more and more sophisticated, requiring full fledged operating system where you can do web browsing and so on, email, etc. It is not like that. It is very simple operating system and very simple cell phones. The VRTX has been used. Another very important aspect of the VRTX is that it was the first commercial real time operating system to be certified by the Federal Aviation Authority for safety critical applications like avionics. To get the Federal Aviation Authority's approval is not easy. You have to show that is not only it has been thoroughly tested, all path covered, etc., but also you have to give a guarantee or you have to demonstrate how many failures can occur over millions of hours of operation. Typically 5 or 6 failures can be tolerated in a million hour of operation. So, very extremely safety critical. As we are saying that it is targeted for products where low memory and low power consumption, cost, etc., are very important. Examples of the products are set-top boxes, simple digital cameras, simple video games, routers, mobile phones, handheld computing devices, etc. Many Motorola cell phone versions use VRTX-MC. There is also another flavor of VRTX, the SA version. SA stands for scalable architecture. It's POSIX compliant. So, all the features are there in this. We should infer just by looking at the POSIX ACTI compliant, means all the required features for a real time operating systems are there, but VRTX-MC does not support all the features. Designed for medium and large applications, good I/O support, memory protection. So, the user programs or the application programs and the kernel operate in different memory space, very important for large product development. On the other hand, VRTX-MC, it works only for small applications. It would be difficult to develop for larger applications. Reduced interrupt and task switching latency. The other important features: support for priority inheritance and multiprocessing. We had discussed resource sharing is in a non-trivial application. The tasks need to share resources, and therefore, priority inheritance becomes important for resource sharing among real-time tasks. So, I hope all these terms are making sense, and system calls are fully preemptible and deterministic. We also know the implications of a non-preemptible system call and the jitter that can introduce due to a non-preemptible system call. Here system calls are preemptible and deterministic. Many systems have been developed on the VRTX-SA. One prominent example is the Hubble Space Telescope. So, here the telescope is sent to the space and it sends images from there. We will look at another very prominent real time operating system called as VxWorks, manufactured by Wind River Systems. Actually, now the Wind River Systems, which was a large player in this real time operating system area, has been acquired by Intel in 2009, and the VxWorks, the development history is that the VRTX operating system was licensed by Wind River Systems. So, they said we will develop an operating system based on VRTX. So, they could get the source code and so on, and naturally many features of VxWorks are similar to VRTX. We have just seen the VRTX, and the Wind River Systems, they had noticed that VRTX is extremely small operating system, lacked most of the facilities even to be called as operating system. So, many said that VRTX does not work as a operating system, and this is supposed to be a, what you can say, joke or something. So, this is a VRTX operating system which works, or VxWorks. So, that is how they have named it VxWorks, just to, and later of course, the VRTX license expired, it was for a certain period, and therefore, the source code etc. is entirely different, but features are similar. So, deliberately they had developed features based on different source code, so that there will not be any licensing problem later. The VRTX, as we were saying, that supported very basic features originally, only 4 KB code, and lacked, for example, file systems, development environment and so on, and VxWorks provides all this. It has added several features and development environment. Even it can work on multiprocessors, symmetric multiprocessors, multitasking kernel, and preemptive round robin scheduling. So, you can implement RMA, EDF, etc. Memory protection between the application tasks and the kernel. Okay, the user applications are isolated from the kernel. So, development of the applications becomes easy, and we were discussing the other day, if protection is not there, each time your application develops as a bug, it will crash the system and becomes very difficult to debug and correct the bug. The features that are expected for a good real time operating systems, POSIX compliant, are all available. Semaphores with priority inheritance, both binary and counting semaphores are there. Cell based user interface, file system support, and also there is a VxSim simulator. We will just discuss the role of the simulator in the VxWorks, I think, in the next slide. Symbolic and source level debugging is supported, and not only that, not only the simulator, but also you can monitor the performance of various system calls and application tasks and so on. But it was a monolithic kernel operating system. It is real time POSIX compliant, and in addition it has also several additional APIs, and it is a host target approach. We know what is a host target approach. Develop the application on the host and download the application onto the target board, and provides protection of the application tasks from the kernel through MMU, and also the virtual memory, virtual to physical memory mappings achieved through MMU. The application development can occur either on a Unix or a Windows host. You typically, while developing the application, use a cross compiler that comes with the operating system. You can run the application on various target architectures, and also initially run the application on the host itself through the simulator VxSim. So, first you simulate the running on the host using VxSim, and once it works or you are satisfied, you download it to the target architecture and again run and check for performance and so on. And if it works satisfactorily on the target architecture, then you fuse the application on a flash or a ROM. And it has also a development environment, integrated development environment, consisting of the operating system, application building tools like cross compilers, debuggers, support for host to target communication. You would like to download the application to the target and also check the performance, need to debug also the target. So, that is taken care by the communication. You can run, monitor the run and debug on the target board, and of course, the IDE also consists of the simulator that helps you run it on the host. As I was saying, that extremely popular operating system, I think we had discussed some time back that the Mars rover, Mars exploration rover, the Spirit and Opportunity, they used the VxWorks operating system. Not only that, several other spacecraft used the VxWorks. For example, the Deep Impact mission. So, this is the Mars rover, the Boeing 787 airliner, Linksys wireless router, the Siemens Medical Solutions also use VxWorks to control real time events of the MRI scanners, and also widely used in industrial robots. So, a robo here is working on some samples here. So, these many robots of this type are powered by the VxWorks operating system. So, right now we are looking only at the features being supported, the kind of application, whether it is for a small embedded application or medium or large application, the kind of features, whether POSIX compliant, etc. So, depending on the application, appropriate operating system needs to be selected. The Lynx also is very popular, first released in 1988, fully preemptible, reentrant and compact operating system. Initially the name of the company was Lynx itself, and it is, as the name says, it is a Linux based operating system. Linux is open source, and definitely they have used the Linux code and developed based on that, and possibly they developed many other software under their company, and that is why they have changed it from Lynx to Linux. And over the years, they have moved from a monolithic architecture to a microkernel design. Initially, they started as a monolithic architecture, but later, due to the advantages of the microkernel design, especially in real time applications, they have moved to the microkernel design. I hope everybody knows and remembers what is the advantage of a microkernel design for a real time application compared to a monolithic kernel, and also its disadvantages, and also for traditional applications, the advantages and disadvantages of a monolithic versus a microkernel architecture. The microkernel is only 28 kilobyte in size, provides the basic services, basic scheduling, interrupt dispatch and synchronization, and of course, very basic memory management. And all other services are provided as kernel plugins, and the kernel plugins are multi-threaded. So, multiple requests they can handle at a time. The kernel plugins can be the I/O, the file system, the TCP/IP, streams and sockets, all work as the kernel plugins, and these operate in the user space. All these file systems, stream, socket, I/O, etc. at the user space. The microkernel, I think we had also seen earlier that the idea is to minimize the kernel size, and we had also distinguished between what is a kernel and what is a user space. So, does anybody remember what is the difference of a kernel with respect to the user space applications? With respect to, see, there are different aspects you can compare a kernel with respect to a user space application, but what about the memory management? What do you think? What is the difference between a kernel and the, yeah. So, typically the application, the user applications or even the KPIs, they are operate in a virtual memory environment where they are operate through MMU, and then the page swapping misses etc., faults, page faults etc., occur, but a kernel code is resident. Okay. So, let us proceed. The kernel in a microkernel, the idea is to minimize the kernel or the memory resident part, modular and small, typically few kilobytes to hundreds of kilobytes, and becomes easier to develop a small kernel, easier to port to a different hardware, easier to maintain and extend. And we had seen that different operating system vendors use different facilities for the kernel to support, but typically they all support some basic process management, basic memory management and inter-process communication. So, this is a monolithic kernel where all the operating system facilities or the services operate in the kernel mode, file system, process manager, memory manager, drivers and so on, and the applications in the user space. On the other hand, in the microkernel approach, the applications and many of the operating system services, they operate in the user space, whereas the microkernel operates in the kernel mode. We will not discuss, please try to recollect the relative advantages of the microkernel and the monolithic kernel approach. The links can also function as a multipurpose Unix operating system. You can run soft real time applications, even non real time applications, compilers etc. This the kernel provides the basic services and other services are the kernel plugins. And unlike the VxWorks and VRTX, Linux is a self-host system. You know, a self-host system is one where the real-time application runs on the same host on which you develop, whereas VRTX and VxWorks, you develop it on a host and then download it to a embedded application. Here the applications, the compilers, debuggers etc., they run through the MMUs, providing virtual memory, that is large memory address space, as well as protection from the kernel. I am sorry, the kernel is protected from the user space. If you look at more detailed features, it supports a single scheduling policy, which is a fixed a fixed priority preemptive scheduler with 256 priority levels, and the clock frequency is also fixed at 100 Hz, which is timer resolution of 100 milliseconds. So, if your application requires the timer setting to be less than a few milliseconds, obviously it will have difficulty. This is another popular operating system. The QNX Neutrino is the kernel. The QNX Neutrino, just read them together. The QNX Neutrino, it is again a Unix like operating system, POSIX RT compliant. It was actually developed as a student project. Two computer science students in the University of Waterloo, 1980s, Gordon Bell and Dan Dodge, they developed it as a student in 1980s, and then both these persons, they set up their own company, the QNX Corporation, and they started developing. Initially, of course, it had very basic features as a student project, but they kept on developing this, and it became a full-fledged and a good real-time operating system. It is a microkernel design. the kernel provides the thread and time services, and since it is a microkernel design, you can easily allow or turn off any functionality that you do not require. You can add new functionalities, remove functionalities not required, and so on. And as with any microkernel operating system, here the drivers, applications, protocol, file systems, etc., run outside the kernel, and memory protected user space through MMU, making it simple to develop and debug, etc. Not only that, even if a component fails, it can be restarted without affecting the components of the kernel or the system crashing. In a monolithic operating system, if any problem occurs in any of these applications while running, it would result in a system crash. Here it does not, you just restart it. And also good application portability, feature of any microkernel operating system. POSIX RT compliant. Here most of the services run as user process. Here the microkernel is taken to a extreme end, like we had seen microkernels where they provide many facilities in the microkernel itself. Here even the process creation is done through a proc, which is also runs in the user process. Memory management also as a user process, of course with the help of some basic microkernel routines. And if you are looking for a distributed application development, this can be used. QNX is naturally extended to a distributed operating system because of the strict microkernel architecture. Now, let us look at another very popular operating system, the Windows CE. It is very popular for handhelds, mobile, the portable digital assistants and the mobiles, and the development started 20-25 years back, and now you have the Windows CE 6.0, which is the latest version. It is developed over several versions and revisions. It is a 32-bit operating system and naturally supports a 4 gigabyte virtual address space. Again, it divides into the kernel and user space, just like any other Windows desktop operating system, and it is reconfigurable. You can configure it to be very small and feature rich. The smallest configuration is called as the MinKern, only 350 KB size, but of course most of the facilities would have been turned up, no graphics, Windows support, etc. Supports multiple processes, multi-threaded, DLLs, dynamic link libraries, virtual memory management, comes with support for large number of IO device drivers as any Microsoft operating system. So, these are some of the important features, the Windows CE. The memory model of Windows 5 had one limitation, that is 32 process limit. So, the maximum number of process that this is of course carried over from the legacy of CE 1.0, 2.0, etc. You can at best have 32 processes, and each process can have a 32 MB memory. So, just see here, the entire virtual space is not available. The memory is divided into slots and they use those slots. The shared memory is half of the user space, upper half of the user space. So, this is how it looked like. 2 gigabyte kernel space and 2 gigabyte virtual memory for all processes, but in the virtual memory they do not reside just anywhere, just like a traditional operating system. They have slots here for the 32 processes, each one is 32 MB, and there is also shared memory. This portion is earmarked for the shared memory. So, the 2 GB user space is divided into the shared memory and the slots for the user processes, naturally a severe restriction for operating system. Of course, this has been removed in the CE 6.0. One thing that need to discuss is about the interrupt handling in the Windows CE. The device driver, as we are saying, with any operating system which can give a fast response to interrupts, must have two parts. One is a tiny kernel mode ISR service routine, which basically decides how to handle the interrupts, and it can queue a interrupt service thread or a deferred procedure call, which does the bulk of the interrupt handling work, but the basic work deciding how to handle the interrupt etc. is done by the tiny kernel mode. So, same thing is supported here, which is of course very desirable for a real time operating system. When an interrupt occurs, the kernel saves the state of the currently executing user mode code as soon as the instruction completes, and then the kernel invokes the ISR to handle the interrupt. But most of the responsibilities of the ISR is delegated to a deferred procedure call. The main reason for that is that the ISRs typically run in the kernel mode. They have a very small stack and the local variables are limited, and also since it is kernel mode, most of the interrupts are masked. By making it most of the processing in the deferred procedure call, you can reduce the time the interrupt is masked. Other features of Windows CE that we need to discuss is supports priority inheritance for resource sharing among real time tasks. But before Windows CE 3.0 and even the Windows NT and so on, it could undergo unbounded priority inversions. While discussing Windows NT, we had discussed about this aspect, that resource sharing, even though the Windows NT had many desirable features for a real time task, for real time application, for example, real time priority levels as well as dynamic priority levels and so on, it had difficulty with resource sharing. Unbounded priority inversions could occur. Fast context switch, and each process has its own page table. The Windows 2000, which has each process has own page table, but here they share a single page table. And of course, does not support multiprocessors, but again we can't just say that it does not support multiprocessor, because we are just talking of some versions of the WinCE, maybe the later versions they support multiprocessors, the multi-core processors. And as we are, I think we just mentioned this one, that Windows 5.0, Windows CE 5.0 and earlier to that, only 32 simultaneously executing processes were allowed, and this is too small number of processes, especially for larger applications, considering that the kernel itself takes up many processes. The kernel itself, the device drivers, the file system etc., they all are counted as processes. So, this 32 gets reduced, and as we were saying that in 5.0 before that the processes had 32 MB address space limit compared to 2 GB for the desktop versions. And the Windows CE .NET, easy to develop mobile applications, support Bluetooth, IP6 etc. is part of the operating system. IP version 6 supports Kerberos security, because mobile applications security is important. The secure socket layer, Kerberos etc. are supported. Okay, so this is the security service, and it's actually a several hours of discussion on Kerberos and even secure socket layer. We can have several hours of discussion on security. So, maybe we will not spend time now. If possible, towards the end we will see if we can discuss little bit or an hour or so on the security services in operating system, but at least you can just read this up, some basic aspects of Kerberos and secure socket layer, how these provide security and how they help with authentication and crypto attacks and so on. So, you can build and test applications on Windows 2000 and XP desktops using emulation for WinCE.NET, helps in application development on a larger platform Win 2000 or WinXP, and then make it run on WinCE. Another popular operating system which is become very increasingly, or it has suddenly gained large popularity, is the Symbian operating system, specially designed for mobile phones, and it became very popular once it was acquired by Nokia in 2008. And not only that, Nokia made it a open source from February 2010. So, now anybody can develop applications, can extend the kernel and so on, and large number of operating systems, the mobile phones, almost half of mobile phones you see people holding, they run the Symbian operating system. It's not a exaggeration to say that it is the world's most popular mobile phone operating system. Next to the Symbian, I think, is the Windows CE, which has only some 10% or so, or 12% uses as a mobile phone operating system. So, microkernel design, and like other operating systems, it is multitasking, as memory protection, and one important feature is that the CPU is switched into a low power mode whenever application is not directly dealing with an event. So, it keeps track of which application is dealing with what event, and if none of the applications is dealing with an event, it immediately switches into a low power mode, very important feature required in any mobile phone. And another one which developed just couple of years back, 1 or 2 years back, is the Android operating system. Again, a mobile phone operating system specifically targeted towards the mobile phone, based on the Linux kernel. See here the Linux kernel, all these services are there. On that, specific libraries and specific applications, for example, security and so on, are built on this. It is just a couple of years old, but its usage is growing very rapidly. Free operating system again, and possibly because of the popularity that the Android operating system, the interest that it was developing, it was generating, maybe the Symbian, they made it open source, just by looking at the Android operating system, the way it was increasing in popularity, just a couple of years old, but already has captured some 2 to 4% of the mobile phone market. So, these are two operating systems, possibly they are going to become more and more important and popular in not only the mobile phone space, but other real time applications as well, because other applications also they need capability to connect with other devices and so on, the future applications, and lot of literature available on these two, the Symbian and the Android operating system. So, I would request you to prepare a write up, survey the material available on the net, and prepare a report which is basically a bonus problem. Spend some time with the reports available, understand their features, their implementation, compare their features and advantages and disadvantages. And please submit it before the end semester. So, we have briefly surveyed the features that are available in some of the popular real time operating systems. There are many more real time operating systems that are available. Some are free, open source, some are priced, but it's very difficult to include all of them. There are several dozens of them. So, we have just looked at some 8-10 operating systems which are highly popular, used extensively in many of the embedded and real time applications. Now, let us try to answer one question. Suppose you are asked to select a computer system for a specific application. Let us say you are a college teacher in a college, or maybe a engineer in a company, and then your principal or your manager in your company comes and says, see, we need to buy a computer to do an application. Let us say we need to implement a web service, we need to host the web pages of our organization, of our company. So, can you select a computer for this application? And of course, the cost etcetera would be given to you. Let us see, we have budget of 1 lakh or something, 1 lakh, and then the application that we were trying to run is hosting a web page of the organization. It should be a web server basically. So, naturally you will find that there are dozens of manufacturers who can quote for your product and satisfying your cost. Then how do you select the computer out of all those which satisfy the cost etcetera criterion? How will you select an application which will provide the best service? And the best service is, let us say, provides the fastest web application, web server for, let us say, a fixed number of users. Let us say the manager or the principal might say that, see, we will generate only about 300 hits per second or something, 300 hits per minute. So, what do you do to select? Yes.
Processor speed.
So, how do you measure processor speed?
Million instructions per second.
MIPS. So, he says that we should look at the MIPS rating of the processors and then select. What about any other have different ideas? How do we select the computer for this? Because it might happen, no? Someday your boss, somebody is going to come and say that, see, you are the responsible person who will select the computer for a specific application.
Actually, for web service, the hits might request to retrieve the information.
Yes.
For that purpose, a DMA controller or required. Like always, it is not that always a processor is used. Always.
True. I mean, see, processor rating is one where it says that how many instructions it can complete per second. That is what he says, millions of instructions processed per second. And of course, that would also include the IO instructions. So, in some way IO is there. So, not clear actually what you are saying. Is there anyone else who would like to tell anything?
memory, sir.
Yes.
Memory.
Memory, yes. How does memory help?
Suppose
We'll put an upper bound on how much memory can be used. Expected
Permanent
amount.
memory.
No, no. He said that we should look at the memory. So, what should you look at memory? Would you insist that we should have 2 GB memory, 4 GB memory, or
speed of the memory as well as the size of the memory.
I mean, what say you will try to maximize both? Is it? Is it?
A trade-off between a cache memory and the permanent memory.
So he says that not only the main memory, he will also look at
Also
cache. So then, I mean, how do you look at it? You will just keep on comparing. Let's say one computer has more main memory, less cache memory, and another one has more cache memory, less main memory. So how do you compare all this?
Depending upon how much data do we have.
So data, a web service for this thing, organization, it might have some, let's say 10,000 pages, HTML, 10,000 HTML pages. So that's what the data would be.
So we will have to look what is the basic requirement of our applications.
What do you mean basic requirement of the application?
The minimum space we are going to run our web server
Space, you mean hard disk or memory? Or
and memory space.
no, memory is virtual memory. No, it doesn't really
Cache,
cache.
multi-core, it having a 2-level caches.
No, extremely confusing. See, all these are virtual memory, and then the cache. No, it doesn't really fit everything. Anyway, so let's look at. See, all of you are giving very divergent answers. So let's see what do you do. As he said, to start with, that we can use MIPS, flops, etc. But these are highly misleading and indicate almost nothing. That is why I think somebody said that these are more misleading or misleading information about processor speed. Somebody gave that acronym. MIPS is a misleading information about processor speed. Why is it misleading?
But sir, high MIPS rate does not guarantee that CPU performance will be more.
High MIPS rating does not guarantee that CPU performance will be more. Why is that?
The average mix should be.
This is MIPS is average, no? Millions of instructions. So you run the instructions and then find out how many millions of the instructions execute per second. That is the average basically. Per second means average.
And then ultimately the throughput should be. Mix alone may not guarantee throughput.
Why?
It does not say that specify the instruction type that is getting inputted or getting
Okay.
erased.
Okay. So the MIPS, as he says, that in MIPS it does not say which instructions are considered to compute the MIPS rating, and typically the vendors use the shortest instructions. See, all the different instructions take different number of cycles. Some the IO instructions etc. may be taking hundreds or thousands of cycles, and some instruction may be taking tens or few cycles, and they deliberately use the shortest instructions. They select those instructions. So basically, you determine MIPS by running some program, right? That is how you determine the MIPS, and they select those instructions or that kind of program where you have some instructions, the shortest instructions are executed. Naturally, MIPS and flops are highly misleading. They do not tell about even the average performance with respect to all the instructions, only the peak performance, right. So, if your application used only those shortest instructions, then what would be your performance? That is what it basically boils down, and everybody noticed that, and later the vendor started quoting the performance in terms of peak MIPS and peak flops. They agreed that see the MIPS is misleading, so not much use, and peak MIPS and peak flops is possibly a more meaningful thing. But then even if you know the peak MIPS and peak flops, your application is not going to use only those shortest instructions, is not it? So, just by knowing the peak MIPS and peak flops does not help. Might choose a computer which has a high peak MIPS and high peak flops rating, but finally when you run your application, you find that it is running extremely slow and even much worse than some computer which had a very low peak MIPS and peak flops rating. So, that is what this slide says, that many manufacturers quote the peak processing speed by considering the shortest instructions and ignore the other instructions which take large time, very misleading. And later the synthetic benchmarks were developed to overcome the problem of the MIPS rating, because MIPS does not say anything at all. If you choose based on that, you will be highly disappointed that your application will even run slower than the slowest MIPS computer, right. If you had no choice of several and you choose the MIPS rating, the one that has highest MIPS rating, you will be disappointed that possibly the one which had the slowest or the smallest MIPS rating, your application could have also run faster than that. You could observe that it is running faster. So, the synthetic benchmarks were developed in 1980s, towards the end of 80s. Many synthetic benchmarks existed. The idea behind synthetic benchmarks is that in a typical application, when you run, a typical means you run different applications and then average out. That is what is a typical or average application. You run different types of application and then keep track of what kind of instructions are executed with what frequency. So, basically you find out the average frequency of execution of different instructions when you run a application, and then a synthetic program is written. It is a synthetic program because it does not do any meaningful thing. It just has that distribution of the instructions. For example, ALU instructions 10%, IO instructions 10%, conditional instructions 20% and so on. So, a synthetic program, when you run it, you find that the instructions that are executed by the synthetic program, the average distribution of the instructions is the same as a typical application. You run different types of application, a networking application, a data processing application using some DBMS, and then a user interface or a browser and so on. Various types of applications you run and find the average distribution, and then develop the synthetic program which has similar distribution, so that if you run the synthetic program on different computers, then you will have some idea that how the average program will run, right. So, the vendors, they started quoting on how many of those synthetic programs it can run per second. So, the typical synthetic benchmarks were the Whetstone and Thrystone, Linpack, etc. These are popular benchmark programs, synthetic benchmark programs, and the vendor started quoting in terms of the benchmark programs, saying that how many Whetstones per second, how many Thrystones per second, etc. But again, this had a problem. The problem is that the code for this is publicized, the source code is publicized, the Whetstone, Thrystone, Linpack, etc. is publicized, and the vendors soon they optimized their compilers for these source code. For example, if there is a instruction here which has always evaluates to true, an if condition instruction always evaluates to true, then they removed the if condition, right. Some simplifications they did, and of course, later the spec benchmarks were developed, and our focus is on benchmarking real time applications, real time computer systems and real time operating system. So, we will see how what needs to be taken into account to benchmark the real time operating system performance and the real time computer system performance. So, we will stop today. Tomorrow we will continue from this point and try to see how to benchmark a real time computer system and a real time operating system. Okay, thank you.